A hydrocarbon X with a molar mass 26 consists of 92.3% carbon. What is its molecular formula? Solution. Before we proceed with the solution, I would like to remind you to subscribe and click on the notification bell as well, so as to be updated as soon as new videos are being released. And you can as well join the Telegram channel for better communication. The link is in the description box. In the question above, we are dealing with a hydrocarbon. Hydrocarbons are compounds that consist of carbon and hydrogen only. In the question above, we are given the molar mass of the hydrocarbon, we are given the percentage composition of carbon, but we do not know that of hydrogen. So we are yet to know the percentage composition of hydrogen. Do not forget that hydrocarbon is made up of carbon and hydrogen. So since we are given carbon and dealing with percentage is not yet 100%, that means there is a part of it which hydrogen is occupying. So that percentage of hydrogen is what we'll be calculating first. So let's do that. For carbon, we have that to be 92.3%, the percentage composition, and for hydrogen it remains unknown. So to get hydrogen, we'll be subtracting the composition of carbon from 100%. So 100% minus 92.3%, which gives 7.7%. So we've gotten the percentage composition of hydrogen to be 7.7%. Yeah, so let's continue. The question itself says we should find the molecular formula of the compound, and before we can get the molecular formula of any compound, we need to know the empirical formula, and that's what we'll be doing next. To get the empirical formula, we need to know the exact number of atoms of each of the elements present in the compound, and to do that, we'll be having it in a tabular form, working for both simultaneously. We have carbon and we have hydrogen in a tabular form. So the first thing we have on this side will be the percentage composition by mass. For carbon, we have 92.3%. So we have 92.3 here. Then for hydrogen, we have 7.7. Then after this, we'll be stating the relative atomic mass of each of them. For carbon, it is 12, and for hydrogen, it is 1. The next thing to do is to calculate the number of moles of each of the elements, which will be serving as the number of the atoms present in the compound. And from moles, we have moles to be mass over molar mass, but in this case, since we are dealing with each of the elements, then we'll be working with the relative atomic mass. That's why we have it to be relative atomic mass here instead of molar mass. So here we then see moles. So dividing both, so say 92.3 divided by 12, and here we have 7.7 divided by 1. So dividing this, for carbon we have 7.7, and for hydrogen we have 7.7 as well. Now the next thing to do here, after getting the number of moles, that is the amount, is to find the simplest ratio in which they combine. Since we are writing a chemical formula and we don't want to have a subscript of decimal values, then we need to have a simpler value for each of them, and to do that we'll be dividing by the smallest. But in this case here, considering carbon and hydrogen, we discover they both have same values, so we can just divide both sides by 7.7. So this side will say divide by the smallest. So say 7.7 divided by 7.7, 7.7 divided by 7.7. This gives 1.0 and this gives 1.0. The simplest ratio now will then be 1:1. Then empirical formula equals C subscript of 1 here. Since 1 is insignificant to be written here, then we just have as C alone. Then same thing applicable to hydrogen, so we have H. So the empirical formula is CH. Now, having gotten the empirical formula, let's move forward to finding the molecular formula of the compound. For the molecular formula of the compound, we'll be using the relationship that says molecular mass equals empirical formula mass times N. So in brackets we have N, where N is a whole number multiple. Molecular formula comprises of a multiple of the empirical formula. Since we have molecular formula to be a multiple of empirical formula, multiple in the sense that it can comprise of one or twice or thrice of the empirical formula. At least the empirical formula is a unit of the molecular formula. This makes us to have the molecular mass as well to be a multiple of the empirical formula mass. From the relationship above, we are given the molecular mass from the question stating that the mass of the hydrocarbon is 26, but we do not know the empirical formula mass and we do not know N. But we can get empirical formula mass from the empirical formula we've gotten earlier, while N remains unknown. So for empirical formula mass, write the formula CH. This means we are summing the atomic mass of each of the elements present. The atomic mass of carbon is 12 plus hydrogen, which is 1, and this gives 13. So we have 13 grams per mole. Going back to the formula, N remains unknown, hence we'll be making N the subject. So N equals molecular mass divided by the empirical formula mass. Which is equivalent to the molecular mass from the question is 26. So we have 26 grams per mole divided by empirical formula mass, which is 13. So dividing this, we have 2. Getting N to be 2, we can then conclude that molecular formula, which is a multiple of the empirical formula, equals empirical formula into bracket of N. So here molecular formula will then be the empirical formula we've got in CH into bracket of, we've gotten N as well to be 2. So we'll be using these two to multiply the subscript of each of the elements present, and this gives, here we have subscript of 1, 1 times 2 is 2. Here subscript of 1 as well, 1 times 2 gives 2 as well. So we have C2H2, and this serves as the final answer. We've just concluded the solution to the question, and we've gotten the molecular formula of the hydrocarbon X to be C2H2. That will be all. If you are yet to subscribe, do not forget to subscribe and click on the notification bell so you don't miss out on more videos like this. You can leave your comments in the comment section below, like and share the video as well, and also join the Telegram channel via the link in the description box for better communications. Thank you.